Everyone to our seminar around moisture measurement in bulk solids. I hope you're all doing well, and I hope as you join this seminar, you'll get a good understanding around the technologies and how you can bring benefits to your process using online moisture measurement. Now, for those that haven't been to a seminar before, I'm just going to go through the GoToWebinar interface that you see in front of you on your screen right now. You can change the window of how big the webcam is by clicking the little line up between the interface between the slides and the webcam interface as well. You can enter your questions on the right-hand side in the Q&A section. You can do that anytime, and we'll get to your questions at the end of the seminar. We've also added a couple of handouts for today's seminar. One of them is around further information for moisture in bulk solids, and another is around the dielectric constants that Gustavo will go into a bit later. And then you can see the other settings on the right-hand side. We've left probably about 5 to 10 minutes at the end of the seminar for questions, so this is a really good opportunity to ask anything that you might have on your mind from today's seminar. Now, first of all, I'll introduce myself. So I'm Taylor McCurdich. I'm the industry manager for mining and oil and gas here at Endress+Hauser Australia, based in Sydney. I've been with Endress+Hauser for about 4 years now. And previously, I came from a mining operation role with a large Australian mining company. I'll now hand over to our other presenter for today's session, Gustavo.
Hey everyone, how's it going? We're really excited to have you all here today. Well, as Taylor just mentioned, my name is Gustavo Queiroz. People just call me Gus, and I'm the industry manager responsible for the food and beverage market. And I've been working with Endress+Hauser for nearly 11 years right now. Most of this time back in Brazil, where I worked, where I started as an intern, worked as a service engineer, moved to the product management role before moving to the industry manager role that I'm currently in. So yeah, that's it from my side. So back to you, Taylor.
Thanks very much, Gus. So what we'll go through in today's seminar is we're going to talk a bit around what exactly is moisture when we're talking about moisture in online processes. We're going to also talk about the different technologies for moisture measurement in the online processes. Gustavo will speak around the challenges as well around online moisture measurement in today's age. And then both myself and Gustavo will cover different applications in online moisture measurement around the mining and construction material sectors and the food and the feedstock processes as well. I'll recap with a very brief overview of the diverse portfolio around moisture measurement. And then finally, we'll move on to the fun part, the Q&A session. Now, before we start though, I just would like to get a bit of feedback from you guys. So I'm going to be asking a question. Have you actually managed to adopt online moisture measurement in your process? So I'll give you a choice of 4 options here. First option is yes, and it works quite well. Second option is yes, but it didn't work as expected. Third option is no. Wanted to, but haven't yet proceeded for any particular reason. And finally, the 4th option is no, haven't contemplated this option yet. So we'll give you a few more, a couple of more seconds. I can see the results coming through now. All right. Yep, most of you have voted now. So let's have a look at those results. Okay, so the majority of you, about 43%, have said that no, you haven't done it yet, but have haven't proceeded. And 1 in 5 of you have said yes, you've implemented moisture measurement into your operation, but it hasn't worked as expected. So that may be because you might have used a different technology or something. So we'll go through this alternative technology today, which help clear some of those things up. And for you of almost 30% that haven't contemplated what moisture measurement would be able to be completed on an online process, then hopefully today's seminar will give you a bit more insights about the benefits as well and the value that can bring to your operation. So I'm going to hand over now to Gustavo, and he's going to speak about the history of IMCO to Endress+Hauser.
All right. So thank you, Taylor. Well, most of you already know Endress+Hauser, and for those of you who don't know, we are one of the biggest and largest manufacturers of process instrumentation in the world. And we started our journey back in the 60s, supplying all sorts of process instrumentation. And the moisture offering itself, it's something that is relatively new into the Endress+Hauser offering. That's a company we acquired in 2017. But still, the IMCO company or the IMCO brand is something that have been developing and offering and supplying the technology for a moisture measurement since the 1980s. So we acquired all their expertise, all their knowledge, and now we're working together under the same group. So everything we're going to talk here today is already a well-known technology and is already recognized for several customers all around the world. All right. So moving from the soft talk and really going into really what matters for us here today, which is really moisture. And when we talk about moisture, we're really interested in knowing and quantifying the amount of water. It can be either in gas or solids, which is really our focus here today. We do have, as an Endress+Hauser, we have in our offering sensors that are able to measure water concentration, moisture in gas and air in general, but it won't be the focus of our talk today. Today, we're really going to focus on bulk solids in general. And when we talk about moisture in bulk solids, we have two different approaches. We have volumetric moisture, which the name just gives away what it means. We're basically measuring the volume of water in a specific sample. And we also have gravimetric moisture, where we're interested in measuring the mass of water in a specific sample or product, okay? And you can easily navigate between these two measurements if you know the bulk density of your media, okay? Why is it important for us here today? Most of the online methods, most of the technologies that are available today to measure moisture in a contactless way, in an indirect method, they are all based on volumetric moisture. If your process or if your quality control really need to have this monitoring or have this variable converted into gravimetric moisture, you can easily do it based on the bulk density, okay? This is a very broad overview about different moisture measurement methods. So as you can see, there are different ways for us to do it. Usually the direct methods or lab methods, they can be really time and labor consuming, okay? For example, if you have to do a lab analysis of a grain, depending on the characteristics of the grain, you have to wait, you have to keep the grain in an oven for up to 16 hours, for example, or they usually need to work on, you usually have to do some kind of sample preparation, have to do some grinding, reagent adding. So lab methods are really time consuming and it won't be really our focus here today. We're going to focus on indirect methods, and we're going to focus on one in specific, which is called TDR, or time domain reflectometry. Don't worry, even though the name might sound a little bit scary, as we're going to see in a couple of seconds, it's a very simple and easy way for you to measure moisture, and we have different heaps of advantages using this specific technology, all right? But before we talk about moisture measurement, one thing that we need to have in mind, or one concept that we need to have clear in our mind, is the concept of dielectric constant, okay? The electric constant is a material, it's a material property that every material has, just like density or electrical resistance, okay? The dielectrical constant is really important for us because it will describe how a specific product interacts with an electromagnetic wave, okay? So just a matter of curiosity, you can see on the hands-out section on the side of your screen, you can download a handbook where you have different DC values, dielectric constant values for different products. And we're only able to measure moisture in a very fast and reliable way because of the difference of the electric constant of solids in general, both materials and water. And one of the things that we need to have in mind to understand how the sensor works is that the electric constant will create a resistance on an electromagnetic wave propagation. So let's see how the TDR, or the time domain reflectometry sensor, works. So the concept is really simple and easy. All TDR sensors will have an antenna that also acts as a receptor. And basically what we're doing, we're sending an electromagnetic wave over a waveguide. Okay, so if there is no material, if the electric constant of the media is really low, so the electric constant of air is 1, so it's a very low value, we can see that the wave will propagate and come back to the receptor in a very fast way. Just for curiosity, electromagnetic wave, we're talking about light, so this wave is propagating at a velocity of 300,000 kilometers per second, so it's a very fast traveling time. At the moment we have some product with a high dielectric constant, or if we have the presence of water, which is exactly what we're trying to measure and quantify, the time that this wave will take to propagate will be smaller. So the velocity, the propagation velocity will be way slower, and this is due to the resistance caused by the dielectric constant. So water has a very high dielectric constant, so this would generate, this will make the wave propagation to be in a lower velocity. Okay, I have a quick slide here just to give you a quick summary of everything that I just told, just explained to you guys. So if you really want to go into all the bits and bytes on how the sensor works, you can really go through. You can, we'll be sending the presentation afterwards for all of you guys. But what I really want to show you here right now is how the sensor looks. Okay, so this is a moisture sensor. We have the antenna and the receptor here, and this black area you can see here, this is the waveguide. So this is what you install in your process to really measure the moisture. And just for curiosity, just a curiosity information, we are relating the time with the moisture content, and the time the wave takes to travel from the antenna until the end of the waveguide and back usually takes 10 picoseconds up to 2 nanoseconds. So it's a very fast measurement, and still the sensor is able to do this kind of measurement up to 100 times a second. So it's a very interesting technology that we have available to really give you a very accurate and give you a very quick response time when you need this kind of measurements in the process. Okay. All right, so just a quick overview, especially comparing the TDR with other technologies. Since we're not measuring the electromagnetic wave attenuation, and we're not measuring the capacitance, which is the methods we usually have for microwave and capacitance sensors, the technology that our sensors can be really strong, especially with abrasion. Okay, if you have a microwave or a capacitance sensors, as soon as you have any sort of abrasion on top of the sensor surface, this will impact, or this will create a drift on the moisture measurement. And since we don't rely on the sensor geometry, we're actually just measuring time, this is something that will not affect the measurement at all. So you can have once you're doing the commissioning, you will define, you will create a calibration table, and you can rely that this calibration table will work really well for really long periods of time. So recalibration often needed if you have a microwave or capacitance sensors. Once you have a TDR sensor, this is something you don't have to worry about. And this is a very interesting photo we have here in front of us. This is a sensor that was used to measure moisture of cement, and you can hear that you can look that the accessory gadget that we use to install the sensor is completely worn out. So you can see some very strong abrasion signs here, but still the sensor itself is working in a very reliable way. In addition to a design that doesn't depend on the abrasion, we also use a very stable and strong ceramic to make sure that the measurement is done in a very reliable way. Okay, awesome. Unique wear performance. These are some, I have a table here that usually gives you an overview on what are, let's say, the major effects on moisture measurement, depending on the technology that you use, okay? As you can see, TDR is really, really robust, especially around layer thickness, ion conductivity, and grit size. So these are variables that won't affect at all the performance of TDR sensors. Temperature can be a problem, but the TDR sensors, at least the ones supplied by Endress+Hauser, they have temperature sensors to compensate any eventual drift. The main, let's say, thing that we really need to keep in mind, not only for the Endress+Hauser TDR sensor, the Endress+Hauser technology, but for all the other technologies available in the market, is the change on bulk density. But we have a couple of tricks that we use to compensate and really ensure a very stable and reliable measurement condition, as you can see in this slide here. So as I mentioned, bulk density is something that we really need to ensure, that we really need to monitor and ensure a very constant bulk density. We really have a very reliable measurement. And we can usually achieve this kind of process condition by installing the sensor at the outlet of hoppers and bins. So we have some accessories that allow the sensor to be installed exactly in this condition. So this will give us a very, very reliable measurement because the bulk density of the flow coming out of the hopper is pretty constant, okay? A different trick that we usually use to compensate and really reduce the effects of bulk density variations is installing the sensor on top of conveyor belts. So with this kind of installation, we can ensure that you have a very smooth product layer going over the sensor, and we can have a very, very reliable and repeatable measurement. So these are two of the, let's say, key application installations we have. Lots of customers come to us and say, hey, Gus, hey, Taylor, we really want to measure moisture, but we really want to measure this inside a silo or inside a bin. Is it possible? It is. The sensor will work as well. The only thing that we really need you to keep in mind is always install the sensor at the bottom of the silo or the bin. Okay, so if you install on the side of the bin, you usually have a density gradient on the side of the bin, while at the bottom, while at the hopper, you can have a more stable density, on top of the sensor. And one of the things that really ensure that you have a very successful and reliable measurement is for you to ensure that you have a mass flow profile of your product inside that silo, okay? So when I talk about the mass flow profile, all the material inside the silo is moving. Well, once you open the discharge hatch of the silo, all the material will move in a uniform and homogeneous way. This will ensure that you have, let's say, a new product coming over the sensor, and this will ensure a very reliable measurement. One thing that you need to have in mind, if you have problems with rat holing is when you open the discharge of your silo and only the center of the center material falls out of the silo. This is something that can lead you to false measurements because the sensor will be fixed, measuring one moisture, and won't give you any representative information about the moisture inside your silo. But it's completely possible. If you have rat holing problems, this is a side note or a remark, we have solutions to monitor not only the flow, but also the level changes inside your silo. So just shoot us an email. We are more than happy to support you with that. Okay, now I'm going to hand it over to Taylor because we now have a different poll, and Taylor is our poll leader.
Yeah, I'm the poll leader. Thanks, Gus. So that was an excellent summary around the technical side of the SolarTrend portfolio. Now I want to ask everyone around the challenges. So I think we've got a lot of people that said that they've implemented a moisture device before, or maybe they haven't because they thought there could be quite a lot of challenges. I'm going to ask you guys the question, what challenges have you experienced with moisture measurement in the past? So for those people, if it's not relevant for you, then don't worry about this poll too much. But for those that have installed a device and maybe it doesn't work as intended, it could be inaccurate, or maybe it's given you poor availability. Maybe the device itself was too expensive. That's why you've haven't been down the path of implementing an online moisture measurement for your process. Maybe a challenge that you're experiencing right now is the current method that you have is slow and labor intensive, like lab measurement, for example. Like, do you sample your product stream, take it to the lab, and then maybe it could be up to a shift delay when you're getting that result. Maybe you've experienced that there's no device available for your process, and then we're giving you another option as well for some type of other challenge. So it looks like most of you have voted now, so I'll just close the poll and I'll share some of the results for this one. And half of you have indicated that with the challenges you've experienced with online moisture measurement in the past, it hasn't worked as intended, or it's been inaccurate, or you've experienced some poor availability with the device. That's quite interesting to see. A quarter of you have thought maybe the device is too expensive, or maybe there's not a return on investment for that measuring point. 1 in 5 of you have mentioned that the current method that you're experiencing is too slow and labor intensive. A third of you almost have also just mentioned that nothing's available that suits your process. So quite a lot of feedback, and I just want to thank everyone for that one. I'm going to be now speaking around some application examples. So there was a lot of questions that we got before the seminar asking if it would work in their specific process. So I hope we've managed to incorporate most, if not all, of those questions into this component of the seminar. And the first application I want to speak about is moisture detection in stockpiles. So as you know, in stockpiles, it can be issues where you might have highly localized patches of high level moisture. And then normally to sample the stockpile, you might need to take a few different samples from different locations, composite it up and deliver it to the lab. Maybe that might take a few hours to get the result back. And by that time, the doser that's on the stockpile pushing in maybe has already experienced a problem with the stockpile slumping like that. Or maybe you're spot checking some product that's been bagged, and there might have been an issue with the process and you need to check which bags have got the out of spec moisture. You can easily do this with a handheld device that we have there. You can see in the picture on the top there. It gives you real-time information about the moisture in the stockpile or in different product areas. And you can also use that to be implemented on a semi-permanent basis. So that helps reduce your workload in your lab and then also improve safety in the field. The next application we want to speak about is a mining one. So we've had a lot of examples where customers have implemented online moisture measurement for their dewatered final product conveyors for coal or iron ore fine products as an example. And some of the typical problems that we get is that a lot of sites are implementing like a sampling regime and then they send that to the lab, and then this takes a while to get the result back. And it's also very hard to integrate that measurement of the moisture into the control system to perform some type of rectification. It's all manual. So the benefit of having an online measurement on your fine product conveyors is that you can monitor the dewatering efficiency in real time. Even with a high flow rate like this, you can see here's an example here where the sensor is mounted on a sliding carriage, where the arm is ensuring that there's a nice even bulk density underneath the sensor and there's sufficient material underneath the sensor to get a good reading. And there's also another way that we can do it as well. So in a transfer chute or coming off the head end of a conveyor as well, we can install the device. You can see here it's been welded into a aluminum tiled chute. In this example, And then the solid trend device is located here in the chute where the iron ore material is falling down, so that you can measure the moisture of the material in real time. So that's really big benefit for optimizing your process. The sensor was also originally designed for concrete batching as well. So we know some of the issues with measuring moisture in concrete batching or other type of construction material processes is that small particles like sand can easily absorb moisture. We know for concrete batching as well that the water to cement ratio is important for quality, and the old traditional methods that are used, like the calcium carbide method or the dry and kill methods, can take quite a long time to get the result back and can be pretty inaccurate sometimes, maybe up to 5%. So the solution in this case is that you can utilize a sensor where, if you have a look at the top right hand side there, you've got the material sliding onto the sensor. And because the sensor has very fast reaction time, even a couple of seconds of measurement of material across the sensor will give you a very good result. And there's also filtering inside the device as well. So in the times when there's no flow, then that will be excluded from the measurement going to your control system. There's an example there of a top-mounted sliding carriage. At the bottom right there, you can see the different sensors above the different batching chutes as well. So you can measure the moisture coming from each stream, whether it's your large rocks or your sand or your cement chute as well. And then once you've created the concrete, then you can also measure the moisture in the handheld version that we have. So instead of doing a slumping test that might take a long time and it's quite messy, you can easily just get a few buckets and measure the moisture in real time quite quickly. Another application we've got here is for moisture measurement in furnaces. So as an example, there's quartz sand, but you can use, it really applies to anything that goes into a furnace. So we know with small particles that we're putting into a furnace, the feed has to be completely free of free water so that there's no deflagration. And the residual moisture can be measured in the melting process in a conveyor arrangement, like we saw with the arrangements before, just so that you avoid those safety issues from happening as well. So that's another example of where we can use moisture measurement to ensure the maximum safety for your operation. And finally, the last one I just want to cover from a construction materials example is around the process of creating wood pellets. So some of the typical challenges for this is that the wood chips can be quite varied particle size, quite large particle size, and also very low density. And this can be quite a big challenge for traditional methods of moisture measurement. In this case, we have the moisture device or sensor in a screw conveyor. You can see here, this is the arrangement. This is what it would look like in the field. And it has a very large field of measurement so that you can measure all the wood chips. And the best thing is that because it's TDR technology, it doesn't just measure the moisture on the outside of the wood chips, but it also measures the moisture that has been absorbed into the wood chips. So you get a complete and accurate measurement for your wood processing. I'll hand over to Gustavo now. He will talk about some applications from his side. Gus.
Awesome. Thank you, Taylor. All right, so I put together a couple of applications that are really common and relevant for food and beverage in general. Okay, the first one, especially on raw material receival or grain receival. One of the biggest, let's say, challenges or problems we have when you're receiving grains, especially with the high moisture of the material. This is something that can impact the profitability, because the profitability of your end product. This is something that will affect how much you're gonna pay for that load. And among different problems, we have also transparency of the grain quality. Especially if you're doing lab analysis, you usually can have a very low plant availability, especially if you have to take a sample, bring it to the lab, and do the analysis. This is one of the common issues we have, and especially if you're doing lab analysis or sampling your truck, for example, there's a risk of you getting samples of very good quality or low moisture grains from the top of the truck, while high moisture grains can be under the truck. So we usually have two different approaches to sort this kind of problem. The first one is using a handheld device, just like Taylor mentioned. We can have some telescopic extensions for you to really reach the bottom of the truck, or you can even have an online measurement. So instead of assessing and scoring your load based on 3-4 samples, you can score the whole batch, and you can have a graph just like this one. So based on the moisture content that you have on your load, you can define, for example, what is the maximum storage time in a silo. You can define, for example, if you need to do any kind of drying process before storing that grain. And you can even create some automation with the conveyor belts and say, okay, if the moisture is over a defined set point, you can send these high moisture grains to a buffer tank for reprocessing later, and you can send only the good material to your storage tank and further processing. So this is how. Let's move to the next one. So these are the two solutions: the handheld device, as I mentioned, or the online measurement. It can be installed either at the outlet of a hopper or an assembling arm. So both solutions work pretty well. And usually with raw materials, depending on how they come, you can even have some impurities such as stones, which can be really abrasive and something that can be really damage your sensor. But with the TDR technology, that's something that won't affect at all the performance. So you can have the sensor working in a very good condition, even under this harsh, when these harsh events can occur, okay? Another very common application for moisture sensors, especially in grain processing, in bulk handling in general, is in continuous dryers. Dryers are really high energy consumers in every kind of plant. And if you don't know what exactly you're putting inside a dryer, you can spend a huge amount of energy that are not really necessary. So the best way for you to do this is, at least from a process control perspective and quality control, is to install either a moisture sensor at the inlet of a dryer and at the outlet. So based on the moisture content of the material going in your dryer, you can adjust your drying operational conditions to really make sure that you have a very efficient process, and at the outlet as a quality control. And if you have both measurements, this is a very good key performance indicator for the dryer, and this is the first step if you really want to work towards your dryer optimization in the future, okay? Another very interesting application we have for moisture measurement in the food and beverage industry is for pet food production. So basically, you have to prepare a dough, and the moisture of this dough is really important because it often goes to an extrusion process. If you have a very high moisture content, you won't be able to create the pellets in the shape they have to be. And if the moisture content is really low, the product can become really brittle. So this is something that you can improve your process, especially with time analysis. This is often a very reactive process and often relies on recipes. So if you have a recipe and the characteristics of the raw material changes, this is something that will influence later on. But if you have an online moisture sensor, this is something that you can create an automation. You can really improve and boost your productivity with a very simple solution, okay? And the last application we have also for food and beverage, we have countless applications we can explore. We could spend a day here just talking about this. I separated one for malting process. So basically, once you have the germination, once you get the barley, you have the germination and you have the grain malt, you have to reduce this high moisture grain from 44.5 down to 1.5 or 4%. So these are this is a very high energy process, and having an online measurement can really help you reduce time with lab analysis and can really improve your process by giving you the tools and information, for example, on how much energy you have to supply to your process to really ensure that you have a very precise and reliable control. Okay, so these are just a couple of applications. Again, share with us if you have an application that we didn't cover here. We're more than happy to have a chat with you and explore a little bit more. And now I'm going to hand it over to Taylor because we have one last poll, and Taylor is the poll leader. Taylor,
that's right. I'm the poll leader. So we've got a couple more questions that I'd like to ask you. So now that you've seen, I guess, lots of different applications out there around the SolarTrend portfolio, I want to ask, what does that bring in terms of value for your operation? So either productivity-wise, quality-wise, or other means, what's the value that it will bring to your process each year? If you haven't calculated the benefit yet, or you don't have a rough idea, just select the first one. And then if you have some type of idea around what type of dollars benefit it will bring to your operation, then just click the relevant one for you. All right, so the results are coming in now. I'll give you a couple more seconds to finalize that. Okay, cool. So it looks like 3/4 of you haven't calculated the benefit yet. All right, that's awesome. That's probably something that we can help you guys with. So afterwards, we'll reach out. And if you want a further discussion around what the benefit would be for your operation, we can definitely help you out. 10%, say around $0 to $50,000 worth of value to them, and you can see the rest of them all the way up there. It looks like there's at least one person that says the value to their operation is more than $500,000, which is really good to see. And I'm going to ask you one final question as well. What would the role of moisture measurement be in your operation? So you can just click multiple answers with this one. So is it around the quality argument? Is it around energy efficiency? Is that important for your operation when you're measuring moisture? Is it around the safety side? Do you need to measure moisture before putting in a furnace, or around bulk handling characteristics? Is your material sticking in your chutes because it's too wet? Or is it around that could be also the stockpile side as well, you stockpile something in wet weather. And then finally, the billing side. So is moisture important for you when you're selling your product? And I'll wait a couple more seconds until everyone's voted. All right, let's have a look at that. Okay, I'll just share the results. Okay, so almost all of you said that moisture is important for your quality. Okay, that's very interesting. Almost 1 in 5 of you said there's an argument around energy efficiency, and then 14% said billing, and then some of you also said around safety or handling characteristics. Okay, that's very interesting. So I guess what we want to summarize around the benefits of moisture measurement in your operation is that, yeah, quality is number one. I think we would also agree with that. So whether it's spoilage or to prevent clumping in your product, or if it's because your product is sold or marketed as that specific moisture level. The second category, I think we will classify as energy. So whether it's drying, so material that needs to be dried, you know how much exactly moisture is going in, so then you can adjust your burners effectively. The billing, number 3, yep, that's what we had, 14% billing. And this is around the weight of the bulk solids. And then finally, the safety side. So melting processes to make sure that, let's say, for example, recycled materials that are recycled, the free water doesn't evaporate abruptly in the oven and cause any damage there. So I guessed right, that's not bad. Okay, so I'm also going to review the SolarTrend family as well. So we had a lot of different applications, and you can imagine that there's also a wide and varied portfolio that can answer most of those applications. The MMP20, which is there, the handheld device, And then we have the other ones that we have across that have been highlighted, which are the inline moisture sensors. So depending on if it's a abrasive process, if the head needs to be replaced or not, whether the bulk density is low or high, whether the conductivity changes as well, the device will be selected for you by us here at Endress+Hauser. And we also have a range of accessories as well that will help assist maximize the reliability and accuracy of your measurement for inline moisture sensors. You can see down here, you've got the sliding carriage, you've got a number of different assemblies from us, and you've got the display as well that can be used for commissioning, and you can also see the variables from there. So that is around the portfolio. And just to summarize around what makes the SolarTrend portfolio different is that it's an inline moisture measurement for processes, whether they're continuous or batch. I think that's a differentiator between a lot of the other devices out there. It's also a very robust design. So with that ceramic insulator plate there, with maybe with the metallic protection on the head there, it can be in a range of materials, whether it's carbide plated or not, or whether it's a harder type of ceramic or not, to ensure that the wear performance is maximum for your application. You can see that there's a lot of different applications that we can use this device for, and we only covered a fraction of what's possible. We have preset calibration curves as well within the device that come from the factory to make it much easier to commission. So a lot of the common materials such as sand, gravel, it's all comes from the factory with a pre-calibration curve. It's quite easy to recalibrate if you require, and has integrated transmitter with just an analog output. So it can be much easier for you guys to integrate into your plant. So only the time domain reflectometry has those unique advantages with that device. And now it comes with the good part where you get to answer your questions. So I just want to remind everyone before leaving the seminar, make sure you do complete the survey that will pop up, and you can let us know your feedback about this seminar. You can also find this seminar and also all our other ones online at endress.com. So we've got quite a few questions that have come through. Gus?
Yeah, just one comment. We have 3 minutes to answer most of your questions. So if your question is not answered today, we'll come back to you via email. Okay?
Exactly right. I think the first question is is around, I think that's for me actually. So online moisture measurements, can they be applied to filter cakes? Like, are they sensitive to the moisture that's bound chemically? So the answer is yes. So because it's TDR technology, it's measuring the moisture within the entire field of measurement. And that includes any moisture that will be inside, like the capillaries or inherent moisture, as we call it in the mining industry. So you'll be able to measure that inclusive in the TDR device, which is good.
Yeah.
Here's one for you, Gus. Ryan asks, is the unit loop powered?
It's not. It's a 4 wires device, so you need a set of cables for the power supply and a set of cables for the analog output.
Okay, excellent. Maybe another one, Gus, for you if you want.
Yeah, I just want to answer one that appeared here, and it's very often we have some customers asking for it. Taylor is also asking, your mate is also asking if we have X approval for the moisture sensors. At the moment, the SolarTrend offering does not have X approval, but the factory already confirmed that the X approval will come by the end of this year. So if X approval is something that you really need in your process, just stick with us. I'm pretty sure we'll be able to sort this out really, really soon. Okay.
Yeah, that's great news, Gus. We've gotten one more question around the concern around the lifetime of the device, because it is a contact measurement. So what is the typical lifetime of conveyor mounted sensors? So And a few examples is for the quarry. There's one installed in the quarry which has lasted more than 2 years, and that's with aggregate, which is quite abrasive with the hard rock there as well. So it just depends on the application. I think that's really the main message that we want to get there. But it is a contact measurement. The best thing around the Solar Trend is that it can come with an option where we can have replaceable heads, which means as the material wears down on the head, we can swap it out. So that can be implemented into your preventative maintenance regime. You can talk to us about that a bit later.
I think we're running out of time, so I think should we wrap up, Taylor?
Okay, we'll wrap up. For all the questions that we didn't get to today, we'll email you the answers afterwards, and then we can catch up and go from there. Otherwise, if you didn't manage to type in your question on the right-hand side today, or if you think of something else afterwards, just either get in contact with us, or you can also add your question on the survey that comes up afterwards. So thank you very much for joining, everyone. I hope you got a bit of information out of today's session, and have a great rest of the day.
Thank you very much. Have a good one. Bye.